Students, this is mock test based on soil fertility and nutrient management, and this chapter is very important and many questions are asked from this chapter. So, we will discuss different type of questions and their concept and reasons. First question is pyrite content. So, here question is asked about pyrite. Pyrite is very important material, and this material pyrite is acidic, and chemical formula of pyrite is FeS2. So, if we know the formula, so definitely iron and sulfur are present in pyrite. There is another pyrite, chalcopyrite. Chalcopyrite is related with the copper, iron and sulfur. So, in general pyrite is asked, this is very common. Then another question is about acid equivalent of CAN. This CAN is calcium ammonium nitrate. This is a fertilizer and it is known as Kisan Khad. Calcium ammonium nitrate. So, here ammonium is present and nitrate is present. This ammonium cause alkalinity, means tends to increase the pH, while nitrates tends to decrease the pH, acidic. So, that is why the cumulative effect is neutral. So, this fertilizer has zero acid equivalent. If we talk about acid equivalent, so what is acid equivalent? If we apply any fertilizer, then this fertilizer either may increase the pH or decrease the pH. Most of the fertilizers decreases the pH and are acidic. So, if a fertilizer is applied, suppose this is a fertilizer and it is applied in soil, then pH goes down and soil become acidic. So, how much acid is produced? That should be neutralized. So, to neutralize the acid, how much calcium carbonate is required is known as acid equivalent. So, acid equivalent is calculated in terms of calcium carbonate. For example, acid equivalent of urea is 80. So, it means if 100 kg urea is applied, if 100 kg urea is applied, then the acidity created by this 100 kg urea, 80 kg calcium carbonate is required. So, this is the meaning of acid equivalent. So, in case of CAN, this Kisan Khad, calcium ammonium nitrate, there is no alkalinity, no acidity, and its acid equivalent is 0. Now, question is plants show luxury consumption. Luxury consumption means the amount more than its requirement. If any nutrient is present more than its requirement, then its consumption is called luxury, provided that it does not cause any toxicity. Otherwise, if nutrient is absorbed in large amount and cause the toxicity, then it is not luxury consumption. So, there are two things very important in luxury consumption. Number one, high absorption. Number two, no toxicity. So, in general, if we plot a graph between the plant growth versus nutrient concentration, then as the nutrient amount increases, growth increases, then it becomes stagnate, constant, then it start decline. So, this is the maximum concentration where there is no response. This is the zone where no toxicity occur, but beyond this zone when concentration increases, then reduction in growth. So, this is the toxic zone. This is the sufficient zone and this is the deficient zone. So, in case of luxury consumption, this sufficient zone is wide like that, this one. If nutrient absorption become toxic, then graph is like that. Growth increases, then sharply decline. So this type of graph is for micronutrient, where slight excess cause toxicity. And this white zone, it means nutrient absorption is here, increase up to this, but no toxicity occur. So this is for potassium. So potassium is known for its luxury consumption, means plant absorb more and more amount of potassium, but potassium does not show toxicity. So this is the difference between luxury consumption and toxic symptoms or toxic concentration. So micronutrients do not show luxury consumption because their slight excess cause toxicity. So this is common for potassium. Next question is the most commonly used nitrogenous fertilizer in India. So this is urea. Urea is most commonly used, widely used. The reason is that this is the solid fertilizer which contains the maximum amount of nitrogen, and nitrogen is 46%. So this is the solid among the solid fertilizers which contain 46% nitrogen. That's why it is very popular, and there are many other reasons behind it, but the main reason is high content of nitrogen in solid form. Here question is asked about sulfur content in DAP. So DAP is diammonium phosphate. So here in this fertilizer, ammonium is present, NH4 is present, and phosphate ion are present, HPO4 are present. So here no sulfur, there is no sulfur in DAP, so its content is 0%. So sulfur content is 0. So in option this is none of these. And other fertilizers contain sulfur like SSP. SSP sulfur content is about 11 to 12%. Similarly, in case of gypsum, sulfur content is about 24%. So these questions are asked about sulfur content in SSP, in gypsum, but in DAP, no sulfur. Then test of essentiality of plant nutrient was given by, so this is related with the scientist name. So we should remember the important scientists and their contribution in agriculture. So the essentiality of plant nutrient was given by Arnon, and Arnon and Stout gave the criteria of essentiality of nutrients, and these three scientists are also important and we should know their contribution. And Mr. Lich's work is very important, and he gave the law of diminishing return. Diminishing return, as we increase the nutrient dose or input amount, the response progressively become smaller and smaller. This is very important law. Then Blackman gave the concept of limiting factor, how the nutrient become limiting. Then Liebig gave the law of minimum. So these two scientists are important from their contribution, and these two laws are very important, law of minimum and law of limiting factor. Now another question is nutrient necessary for biosynthesis of indole acetic acid. This is IAA, and this indole acetic acid is important for auxin hormone synthesis, and this auxin is important for cell division. This is growth promoting hormone, and in the synthesis of indole acetic acid, zinc is required. Actually, zinc is required for tryptophan amino acid, and this tryptophan is precursor of indole acetic acid. So this hormone synthesis depends on zinc concentration. If there is zinc deficiency, definitely there will be poor synthesis of tryptophan and consequently less synthesis of IAA. And it results into reduced plant height because cell division is reduced. So, this is the reason that whenever there is a deficiency of zinc, plant remain short. So, short internode are the peculiar characteristics of zinc deficiency because of less synthesis of indole acetic acid. The next question is boron content in borax. This question is very important and generally asked in examination. This is the common source of boron, that's why this is generally asked in examination, and it is 10 to 11%. So, remember this 10 to 11% the boron content in borax. A value technique is related with the analysis of. A value technique is used for the radioisotope analysis and it is commonly used for the phosphorus. So, remember this A value technique is used for phosphorus analysis. Then which nutrient is highly leached in soil? So, highly leached in soil, this leaching depends on ion charge. Soil particles are negatively charged, so that's why anions are repelled, move away from clay particles, soil particles, and cations are attracted towards clay particle by electrostatic force. So, electric charge present on ion decide whether it will adsorb on soil surface, attracted to soil surface, or will move away from the soil particle. So, if it is an anion, then it will move away from soil particles, then it will come onto pore space, then it will move with the percolating water. So, anions are subjected to leaching, but this phosphate ions are fixed, they are highly reactive, so they make the insoluble compounds, so they are not leached. Otherwise, other anions like chloride, like sulfate and nitrate move in soil and leaching is high. So, here the nitrate is given, so correct answer is nitrate. Which fertilizer is generally used in pulse crop? So, earlier we have discussed about the nitrogenous fertilizer, which nitrogenous fertilizer is used, that is urea, but here the question is which fertilizer is used in pulse crop, and in case of pulse crop nitrogenous fertilizers are used in little amount, only starter dose are used, and pulse crops are able to synthesize or have biological nitrogen fixation capacity because of rhizobium nodule. So, they have own fixation, they have fixed the atmospheric nitrogen by rhizobium bacteria. That is why no nitrogenous fertilizer is used, only in early stage or at the time of sowing a small amount of nitrogen is used as a starter dose, but phosphorus and potassium are used as a common. So, here urea is not used, and these are single fertilizer, they apply only P, they apply only K, but this DAP provide N and P. So, 100 kg DAP gives 18 kg nitrogen and 46 kg phosphorus. So, this fertilizer is very good fertilizer for pulse crop because it provides both the nutrient, nitrogen as well as P2O5. So, this DAP is, this is the reason why DAP is used in pulse crop, and for potassium application then apply MOP, but DAP and MOP both are used, but here question is asked which is generally used in pulse crop. The options are given, maybe combination DAP plus MOP, urea plus MOP, or SSP plus MOP. If combinations are there, then we will select the combination with the MOP. It is not like that the MOP is not used. MOP is used, but generally DAP is used because it provides both the nutrient. which nutrient is not applied through fertilizer. So macronutrient, micronutrients are applied through fertilizer, but carbon, hydrogen and oxygen are not applied through fertilizer because plant derive or absorb these nutrients either through air or water. So here carbon is not used. Similarly, hydrogen, for hydrogen no fertilizer is used because hydrogen supply is by water. Nutrient mobility concept was given by, so this is very important, this nutrient mobility concept, and this nutrient mobility says that as the nutrient fixation capacity in soil increases or reactivity in soil increases, then more requirement or more application of nutrient to increase its availability to plant. So this concept was given by Bray. And Wilcox is very important, and he gave agrobiology concept. Mr. Leach, we have discussed about Mr. Leach diminishing yield return, and Ball gave 50% yield increment. So this is the concept, yield increment. So this is the fertilizer dose which increases the yield up to 50%, known as 1 Bowl unit. Nitrogen in soil is determined by, so here question is asked about nitrogen in soil. So this is very common question and generally asked, different methods for different nutrients. So this is Kjeldahl method, and Olson method is used for phosphorus, and Bray number 1 is also used for phosphorus, but this phosphorus in neutral and alkaline soil when pH is more than 7.5, and Bray is used for phosphorus determination in acidic soil, and this is Kjeldahl method for nitrogen, and Walkley and Black method is used for organic matter. So these are other options, and we should remember this method for different nutrients. According to Fertilizer Control Order by Government of India, biurate content in urea bibate should not be more than. So here asked about biurate content number 1 in urea, and by Government of India in Fertilizer Control Order FCO. So according to this, biurate content should not be more than 1.5% in urea. When urea is manufactured, so at high temperature, the 2 molecules of urea are joined to make 1 molecule of biurate, and its high concentration is toxic to plants. So that's why its content, its amount should not be more than 1.5% in urea fertilizer. Anhydrous ammonia content. So we have discussed this about anhydrous ammonia when we discuss about the nitrogen content in urea, and anhydrous ammonia contain about 82% nitrogen. So this amount is high, and in case of urea, nitrogen content is 46%, but this is popular fertilizer as we have discussed. The reason is that this is in liquid form, and this anhydrous ammonia is injected into the soil, into deeper layer, and this is a different type of system and not used easily. So a special type of tank and machinery injections are required. That's why it is not popular among farmers. So popular fertilizer is urea, but we should know about the ammonia content 82%. Then it is nitrogen content. So anhydrous ammonia, so nitrogen content is 82%. Anthocyanin pigmentation of leaf of plant is due to deficiency of, here anthocyanin pigmentation. It is purple color pigment when there is a deficiency of chlorophyll, then anthocyanin pigmentation production is more, and because of this anthocyanin, leaves become purple. So when there is deficiency of chlorophyll, and deficiency of chlorophyll is due to many reasons, but when there is a energy deficiency, then ATP production is less, then chlorophyll formation is poor, and the reason behind is phosphorus. So when there is phosphorus deficiency, then anthocyanin pigmentation is more. So this is the reason that under phosphorus deficiency, leaves become purple in color. Sugar translocation from the leaves is generally reduced due to deficiency of. Two elements are important for sugar translocation, potassium and boron. Here potassium play a role by enzyme activation, ATPase synthesis, ATP production, and boron for borate sugar complex. Both are responsible. So here option is given potassium. So if both options are given potassium and boron, then it is a confusing type answer. So both options are avoided. So but if both options are given, then it is becomes very difficult to select the answer. But in fruit crops, sugar borate complex is important. Potassium is also important. So both play important role in sugar translocation. Leaves containing high amount of nitrate but showing general yellowing may be due to deficiency of. Leaves have high amount of nitrate, it means nitrogen is present in soil, but there is yellowing, and yellowing may be due to other nutrient deficiency which are involved in chlorophyll synthesis or protein synthesis, like sulfur, yellowing is there, magnesium, yellowing is there. It means leaves contain sufficient nitrogen, but yellowing is there. So maybe due to sulfur deficiency, maybe due to magnesium deficiency, but here nitrogen is present as a nitrate and yellowing is there. It means something is there which is not responsible, or which is not converting nitrate into protein and incorporation into chlorophyll. It means nitrogen metabolism is inhibited. It means if high content of nitrogen is there but not incorporating into protein. So nitrate reductase enzyme is responsible for this nitrate metabolism. It means nitrates are there but it is not metabolized. It means nitrate reductase enzyme activity is low, and molybdenum is part of this nitrate reductase enzyme. So if there is a molybdenum deficiency, definitely nitrate reductase enzyme activity will be less, and consequently in result nitrate will not accumulate into amino acid and protein, and there will be yellowing. So correct answer is molybdenum. Now which mechanism contribute maximum supply of nutrient to plant? So mechanism and supply of nutrients. So mass flow is responsible for maximum supply. Nutrients are supplied by mass flow, diffusion, root interception, and contact exchange. This phenomena takes simultaneously and its contribution is very less. So mass flow along with the water. So water move in soil and nutrient dissolved in water are absorbed. And diffusion is through a concentration gradient. So nutrients move from high concentration to low concentration. Generally P and K are moved through diffusion. Mass flow, nitrogen is absorbed through mass flow. Which nutrient become deficient in acidic soil? So metal nutrients are available at acidic pH, but molybdenum is available at pH more than 7. So under acidic condition, molybdenum availability become less. Otherwise, Fe, Cu, Mn, Zn, these nutrients are available at acidic pH. Conversion of ammonium to nitrate, this is nitrate ion, take place by, these are the bacteria, actually this is the conversion, ammonium to nitrite and this nitrite to nitrate. So this is the step, and here Nitrosomonas bacteria is present, Nitrosomonas, and here at this step nitrovector. Other bacteria are also involved, but these are too common. So here question is asked about from ammonium to nitrite. So answer is Nitrosomonas, and nitrovector is involved in nitrite to nitrate. Rock phosphate is suitable for. Rock phosphate is a natural deposit and it contains several nutrients, phosphorus, calcium, and in complex form. And this rock phosphate dissolved in acidic soil and release the phosphorus slowly. So it is suitable for acidic soil because in acidic soils acid are present, pH is low, and it dissolved the rock phosphate. So that's why rock phosphate is applied in acidic soils. Then solver is source of boron. So we have also discussed about boron. Another source is borax, and boron content is 10 to 11%, and solver is another important source of boron. Carbon content in organic matter is, in organic matter, carbon content is about 60%, and organic matter contain two important things, organic carbon and nitrogen is about 5%. Can content, so we discuss about the can, calcium ammonium nitrate, so it contains nitrogen in the both form, ammonical and nitrate. Name is calcium ammonium nitrate. So ammonium is present as well as nitrate. Deficiency of potassium and sulfur appear on lower leaves, older leaves. So mobile nutrient deficiency on lower leaves. If nutrient is mobile, then deficiency on older leaves, and immobile or less mobile than on new leaves or younger leaves. So potassium is mobile and sulfur is less mobile. So accordingly, older and new leaves, or older leaves means lower leaves, and new leaves means upper leaves, their position plant. So correct answer is lower and upper leaves. Here potassium, here upper means new leaves means sulfur. The normal CN ratio of arable soil, it is 10:1. So this is the normal CN ratio of cultivated soil. It ranges 10:1 to 12:1 or even 15:1. So, but it range in the between 10:1 to 12:1. By which process nitrogen is lost from soil? So there are several processes. Leaching is there, the percolating water, denitrification under anaerobic condition, volatilization at high pH. So answer is all of these. So there are several mechanisms for nitrogen loss. So this is the reason that very less amount of nitrogen remain in soil. Then which one is organic fertilizer? Organic fertilizer are those fertilizer which contain carbon. So this is urea. So most students have confusion that urea is synthesized in factory. It is a fertilizer, synthetic fertilizer. How it is organic? But urea is organic. Formula is NH2CONH2. And urea is the first organic product which was synthesized in lab by Wöhler. And otherwise, organic compounds are synthesized in living tissue, in animal tissue or plant tissue, but this was the first organic product, organic substance which was synthesized by inorganic compounds in lab. So, remember that urea is organic but not used in organic farming because it is synthetic fertilizer produced in factories. So, this was about the mock test. Thank you very much.